All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be continuing learning about feed-forward neural networks in PyTorch through Gemini, as in Gemini is doing the teaching. We're going to continue the course that I've set up using Gemini. Now, before we begin, yesterday I wanted to quickly try out doing Tamil serialization using the CRD crate, and I was surprised by how simple it was, how easy it was to get started with the serialization. In the past, when I looked into the CRD crate, I kind of, because I didn't know how I wanted to approach it or how I was even supposed to approach it, I didn't really understand, you know, how to get started. So I started by looking at the CRD crate itself and looking at its documentation. And the thing is, CRD itself, like it's a fairly sophisticated crate. There's a lot of functionality in it. But if you're just looking for very simple functionality, very simple, serialized to and deserialized from kind of functionality, you can get started really quickly. So in my case, um, I had CRD itself, and then I installed the Toml crate, which is CRD compatible. So you can use CRD to actually serialize and deserialize your structs. To give you actually, oh, okay, I have the project open here. Yeah, this is how simple it is. All you have to do is install CRD, and then also install Toml, because in my case, I want to serialize a struct to Toml and deserialize from Toml. So you also install Toml, and Toml happens to be CRD compatible. So once you've done that, all you have to do is toml.toString. Toml.toString, and you have to point it to, you have to use a reference to whatever struct you're trying to serialize or deserialize. And also at the top of that struct, you have to use this derive macro with the serialize and deserialize. I'm not sure what to call these, traits or functions or what. I'm yet to understand exactly what this attribute is doing. I've Just a second. Okay, yeah. I'm yet to understand what this attribute is actually doing, because like on a higher level, I understand that, oh yeah, this is, oh, just a minute. Yeah. On a higher level, conceptually, I understand that, yeah, this is making the struct serializable and deserializable, but I would also like to understand exactly how it is doing that. How is it making the struct serializable and deserializable? I'm sure there's certain amount of like code generation going on in the background. I would like to understand how that's working. Another thing I would like to understand is how Toml becomes CRD compatible, and how is it that calling Toml.toString is using CRD. So like I need to understand the connection between all of these. Fortunately, I have Gemini to explain that to me. In another conversation that I'm having with Gemini, I'm going to be discussing this. For now, though, I think I can close this, and um, I think it's here. No, this is burn. Holy shit, I should not open this. Definitely should not open this. That would be a bad idea. I should actually close this because I'm not using it right now. Yeah, yeah. I should probably close this. At the very least, let's um just be in Scratch stuff instead so I don't accidentally so I don't accidentally, you know, open up that project because burn when you have a burn when you have a Rust project loaded with burn added as a dependency, the Rust analyzer takes upwards of about 5 GB or something in memory, and I definitely don't want that happening here. Sorry, zoned out. Okay, so um yeah, I was doing research on yeah, I was supposed to install TorchViz, right? Let's install that as well. I don't have GraphViz installed here. I forgot to install it. I can actually install it right now. I don't remember if I have to install it from the source or if the version available in the apt repo um, is what do you call it? Is up to date. Because I think there was an issue where it wasn't up to date. I can't remember exactly what it was. Hold on. I'm gonna look up GraphViz and I can't even remember if I installed it or if I built it from source or like what was the situation there. Okay, executable packages. Sudo apt install GraphViz. Um, you know what? I mean, I don't think it's gonna negatively impact the performance too much. I could do it on this. Yeah, I could do it here. Give me a second. Sudo apt install graphviz. Let me just make sure. Um, you may also find it useful to try one of the following third-party sites. Okay, precompiled binaries are available attached to the releases on GitLab. Precompiled binaries are available. Let's take a look. I don't think I was using the. Yeah, you know what? No, it's fine because for the basic functionality that I'm looking for, I think just installing from. Wait, do they have an app image? No, they have deb, they have tar xz, they have okay, okay. Wait, I don't remember which Ubuntu I'm running here. Um, hold on. Nah, you know what? Okay, let's not complicate it. Sudo apt install graphviz. Okay, this is gonna install. Right. Okay, so while this is doing its installation, I can install. Oh, I almost forgot. I was supposed to be using UV here. Though I don't think it's going to make too much of a difference if I use UV pip and then use pip for one installation. I don't think it's like it's changing what the final result is going to be. And I don't like I feel like they're both generating packages within the same sort of parent directory. Either way. Okay, cool. GraphViz or TorchViz is installed. That took like 2 seconds. That's crazy. Um, and here is Hold on. I might need to reload this window so like in a new shell, the dot program might be accessible, or maybe it's accessible right now itself. Because usually if you've added something newly to your environment variable, to your path, then it's not immediately accessible. Hold on, that's blocking. Okay, it's immediately accessible. Great, awesome. I can show you examples of what I was talking. Is it gonna render properly here? Yeah, yeah, the one that I'm showing to you where it's being rendered. Yeah, it'll be accessible. What I could do here is I forgot how you split the window. I think it was Control Shift Enter maybe. Oh shit, that's yeah, I made a mistake. That's in that's here. It's I'm not supposed to be doing it here. How do I want to go about this? Because this is in tmux, this is not in the kitty terminal. I forgot about that. I'm gonna have to split the screen in tmux. I mean, okay, I don't need to do all this. This is like way too much effort for like a small thing. um Let me, okay, let's cd into um uh yeah, let's do this. Okay, test graphviz 01. So we're gonna open this up. Let's cd. Okay, all right. And then here we open up this, and over here we want to go into test graphviz. Okay, so over here we're going to create some graph o1 dot dot, because I want to show you guys what the graph code looks like. It's super simple. Hold on. Wait, just a second. Sorry, sorry, I zoned out. Okay, what was I doing? Oh, yeah, actually, there was something I had to do, um, real quick. I'm just gonna set that up. Uh, okay, that's done. Now here. Okay, all right. We can transition back and we are good to go. Right. So, I was going to show you guys, what was it? Digraph? Graph, just regular graph. Digraph is for directed graphs. So when you have arrows, like when you have a direction for the connections, but if it's an undirected graph, then you can just use graph and you provide a name. I believe you can also do it without providing a name, but if you want to give names, then that's an option. I don't remember. We can test that out. Um, okay, so let's say my graph O1. This is one graph. Within this graph, we can define nodes. So we can say node O1, node O2, and then down here we can specify the connection between them. Node O1 is connected to node O2. Then here we call dot. We say what is a graph called? I forgot. Oh, some graph O1. We also specify the format. In this case, it's tpng, and the output should be, yeah, let's just say graph output, because I'm not going to have multiple outputs. So graph output.png. Then additionally, I want to use Kitty's iCat kitten to open up this image, which is graph output.png. Graph output. Am I spelling it wrong? Hold on. What are the files here? Oh, it's graphoutput.pn. That's crazy. Okay, there's our image. We have node O1 and node O2. We can also add more nodes to this if we want. So we can do also this can it can be a more concise syntax as well. We don't need to define the node first and then define the connections. We can just directly define it like this. Let's say I want to add another connection between node 1 and a new node 3. So I'm going to save this, and there's our new thing. Oh, there's another thing worth noting here, which I just noticed this. I believe we might be able to change this layout. I haven't gotten to the more advanced parts of this yet. I have that course set up with Gemini, and I'm slowly learning more and more advanced stuff. Let's change this to digraph, and let's give this direction. Oh, okay. This is vertical. For some reason, I was remembering horizontal. I don't know. Um, I don't know if there's like a setting that we can do in dot. No layout. Default is, I believe, V. No, hold on. Scale input. Uh, hold up. Set layout engine to this. It defaults to so and so. Use external library. Okay, write the output. Okay, I'm gonna have to look into how we go about setting or choosing between um, how we go about choosing between vertical and horizontal. But yeah, so we have dot. We also have we can close this now. We also have torch viz, so I can probably import this. I should probably reopen this project now, so we would have access to this. This is Rust. Let's not do that. Um, I need to select the session. Um, where's, hold on, where's the, for some reason, this specific session is not there anymore. Okay, that's fine. What did I have open? I had this open, and I had this open. Hold on, let me hydrate, and then we can continue. Sorry, zoned out. Okay. Um, where was I? I was okay. Right. So, I was reading the output. I actually don't remember if I read the output of, or I read the response from Gemini. So, after yesterday's thing where Gemini suggested that, you can use this, you can use TorchViz and GraphViz. I don't remember if Gemini gave. Oh, actually, Gemini did. You know what? We could test it out now. Um, so after running backward, is this the one? No, this is the one. Okay. So here, actually we can do it here as well. Um, I have to import TorchViz. Do I need to import something from TorchViz? Import. There's dot and make dot. Make dot is going to return a digraph. What does dot? Oh, dot is another module. What does? Hold on. What does that contain then? Nothing. Okay. Um, this produces GraphViz representation of PyTorch autograd graph. If a node represents a backward function, it is gray. Otherwise, the node represents a tensor and is either blue, orange, or green. Okay, hold on. There's more text there, so I wanna read that. Okay. Blue, reachable leaf tensors that require grad. Um, that is tensors whose grad field will be populated during backward. Then orange is saved tensors of custom autograd functions, as well as those saved by built-in backward nodes. Then green, tensor passed in as outputs. Tensor passed in as outputs. Okay, dark green. If any output is a view, we represent its base tensor with a dark green node. Okay, so these are more like advanced use cases. Maybe I'll get to that at a later time. So, um, how do we go about doing this? Because this is gonna present the output. Oh yeah, I can also render it, right? I can directly render it using I think it's dot render. I think so. Is it? Uh, Wait a minute. Oh shit, I forgot. It was TorchViz that we could use to also define entire entire graphs within Python code. So you have digraph and there has to be a graph as well. I can't remember if there is, but let's see. Hold on. There's digraph. There's just digraph. Directed graph source code in the dot language. Okay, we can explore this. We can explore this later. For now, what does make dot return? It returns a digraph, doesn't it? Digraph might have a render function. Okay, so let's do that. Um, let's say grad graph equals make dot. We want our total sum, and for the inputs, what was the input supposed to look like? Okay, we pass in parameters. Params equals, this is our dictionary, tensor underscore x would be tensor underscore x, and then tensor underscore y would be tensor underscore y. Okay, then grad graph dot render. The file name should be graph underscore output dot png. And I believe we also need to specify the format. Yeah, we need to specify the format. I need to read all of these. Okay, so we have file name, directory, format. Output format would be PNG. Renderer, I can use the default one. Then I'm Gajid. Hello, hello. Welcome to the stream. Um, how's it going? I'm currently trying to visualize the computational graph of one of the tensors in my Python code, in my PyTorch code. I'm trying to visualize the computational graph for it because this tensor was used to calculate the gradients for some input tensors. And while PyTorch is able to calculate those gradients for you using a simple call to, hold on, let me show you here. This. So after doing total sum dot backward, total sum is our tensor, and well, I might as well go from the start. So we have tensor x and tensor y, right? Then we do an element-wise multiplication, and we store the product of that into a new tensor called product tensor. Then we take the sum of all of those elements and store that result into another tensor called total sum. This is a scalar because it's a sum. It's a sum of all of those elements. Um, yeah. So then, because we've done all of these operations, as we've been doing these operations, internally, there's been a computational graph that's being generated for these two tensors so that we can calculate the gradients for them. And I want to be able to visualize that computational graph, which is why we are now using Torch Viz to render, to first write out this computational graph in dot language. And then after that, we're going to use that dot language or that graph representation to render out this graph to an image. Um, what was I? Oh, format. So format equals PNG. I think that should be it. Yeah, yeah. I think that should be it. Sounds interesting. Yeah, I'm like super interested in deep learning. I'm also interested in a bunch of other topics which I've been getting kind of distracted with, but I finally managed to come back to this topic, and this time I kind of want to go all the way with feed forward neural networks. Currently we are focusing on feed forward neural networks. Next, I want to move on to convolutional neural networks, and then recurrent neural networks, and finally transformer-based neural networks. And after that, I'm going to look into more complex architectures that kind of combine multiple different neural network architectures to solve more complex problems. I just had my 3 week rabbit hole in delta compression. What's that about? Tell me about it. I think I've heard of the term delta compression. Let me look that up. Delta compression or delta encoding is a smart data reduction technique that saves storage slash bandwidth by storing only the difference, deltas between similar data points or files instead of the entire data. Oh, it's kind of like how Git stores commits. Like each commit only stores the changes from the previous state. Um, oh, it does also mention here making it ideal for version control, like Git, backups, video streaming, and so on. So I'm guessing it becomes kind of like a chain dependency kind of thing. It's mainly the subsequent stores or saves or versions are mainly only storing the changes that you've made. They're not storing an entire copy of the thing. Can I send links in here? Because I wrote a nice blog post about it. No, links are not allowed in the chat. I can look it up though. Yes, like Git, but more efficient, like way more efficient. I might look into this then. Depending on what it is used for, I might actually look into this because I have been looking into other ways of compressing data for other situations because I plan on working on um, a stream AI voice app that's going to involve TTS, but there's going to be other components. I kind of want to make it distributed, so there's going to be communication involved between multiple machines. So there's going to be like worker nodes on each machine, and one machine is going to be the sort of main one that's dispatching the work. Though I might change that model up a little bit. Either way, for the communication, I did need to look into various compression methods. I looked into something called message pack, I think. I forgot what the thing was called. Because for me, I'm looking more into, well, I mean, technically, this is also doing the same thing. But yeah, I hold on. Let me look that up. Message pack. Yeah, this is a format called message pack that uses its own mechanisms for sort of compressing and shortening or storing bytes more efficiently by packing the data. Though it's not operating directly um, on bytes, it's operating more on higher level concepts like your integers, your floats and strings and stuff like that. But then internally, it's able to pack all of that into smaller amounts of bytes, and so your overall message is going to be smaller. Another thing I was looking into. Another thing I was looking into was going to be audio encoding. Um, because there is going to be audio involved. Audio is going to be generated by the TTS model. So I could use shortening methods for that. And there are libraries that have implemented the various encoding mechanisms and stuff. So I can pick one that works well for voice related stuff or just even a generic audio encoding. Um, let's see what you were saying. It's a oh, hold on. I accidentally. It's a it's a dev to article called I got obsessed with 2 byte deltas and built a delta compressor that actually hits them. Interesting. Yeah, I looked into message pack, but you might want to use postcard. Let's take a look at postcard. Uh, Postcard compression. Um, Postcard compression isn't a single thing, but usually refers to digital image compression to make photos smaller for web, email, and photographic compression. Though, okay, this seems like it's more aimed towards. Oh, dev.2. Dev.2 is a website. No, no, not that postcard. Okay, is there a specific compression method that you're talking about? A specific compression algorithm? Another thing I was looking into is protobuf. That's further gonna kind of shrink down the size, or at the very least, the big blobs of the entire structs that I'm gonna be sending between computers. It's gonna store them more efficiently inside a blob, and then I can send that over. So I mean, I've been looking a little bit into compression stuff myself, compression and encoding, which I mean they both kind of they're aimed for similar purposes. Postcard Rust, yes, protobuf is also great, but more complex. Hold on. Postcard Rust. Postcard supports a system called flavors, which are used to modify the way postcard serializes or processes serialized data. Okay, okay. Serialization with postcard and CRD. Postcard, RPC. What is a postcard use? Well, no, that's a different. Wait. Okay. Yeah, I might actually look into this. Postcard is a no STD focused serializer and deserializer. That's good to know. I was actually looking for no STD compatible serialization and deserialization methods or crates, because I am going to be doing ESP32 programming in Rust, and that a lot of that requires no STD related code. I mean, you can do STD focused stuff as well, but I want to do no STD focused. If you like Rust and Python, you should look into Mojo. You know what's interesting? I did actually look into Mojo a while back. I looked into Mojo back when it was like the news had just come out freshly that Mojo is going to be a thing. I actually did a stream on it. I remember looking into it. There were a couple of things that I read up on it. I didn't get a chance to try out the language itself, but I did get a chance to sort of read the brochure, if that makes sense. Um, and I mean, I found it interesting at the time. I kind of moved on from it later on. There were a couple of reasons. One was I think there wasn't support for one of the platforms that I wanted to work on. I can't remember if it was Linux that wasn't supported or Windows that wasn't supported, or I think it was only Windows supported, or what, I don't remember. And another thing that I noticed at the time was somewhere it was mentioned about, I can't remember. There was something that told me that it's very closed source. And so at the time I didn't look too much into it. It's also possible that there just wasn't stuff out in the open at the time because, like I said, I checked it out when it was brand new. I didn't check it out when, like later on. It is still developing. I did the tutorial. I had or have dev access to Mojo, or I at least had it then. Linux supported now, so it might have been Linux that wasn't supported at the time. But yeah, I remember it was interesting. It was being marketed as um, Python, but like much faster. And they were giving like some crazy numbers in terms of multipliers for how much faster it is. So I think it was a lot of it was getting hyped up because a lot of AI research is being done through Python. So having faster Python code will help people not have to move over to something like Rust. Like in my case, I'm actually moving the Kokoro TTS model. I'm exporting it to Onyx format just so I can then run it in the Onyx runtime in a Rust application. But the Rust part is there's a specific reason for that because I have like an entire system that I'm setting up, a distributed system that's going to use multiple machines. And I kind of want to I want to use as much power of the machines as I can. Closed compiler, I think it's due to finishing some stuff first. Oh, so I was remembering that part right as well. So it was a closed source compiler. You know what? I'm actually glad to see somebody mentioning this somebody mentioning this language. You are one of the few people that I've seen mentioning it after I actually, looked into it. I looked into it maybe, I don't know. You guys are gonna have to go to my VODs channel. I have a VODs channel on YouTube. The link is probably gonna pop up through Nightbot at some point. I did look into Mojo at the time. This was a couple months ago, or maybe a year ago. I don't remember. But yeah, good to know. I did a fractal with basically the same code, less than a second in Mojo and 59 seconds in Python. That's crazy. Now that's crazy. Wait, what is Mojo also running on a C-based interpreter, or is that interpreter written in some other language? Now, where was I with this? Oh, I was gonna export this, right? Um, this is done. Now here we run this, and then I guess I can also add Um, yeah, kitten icat graph output dot png. I think this should work. Hopefully, let's see. I'm not sure. Holy shit, that works. Wait a minute. Okay, so it did export the graph. I need to go back here and change something because um, I think I was trying to read the gradient for product tensor, and that's not possible. If I run this again, yeah, okay. Hold on, let me take a look at the chat. It has its own interpreter. Oh, by the way, the delta compression I wrote is called Xpatch, and you can find it on GitHub and Crates if you want to look into it later. Oh, cool, cool. Yeah, I'll check that out. I'm sorry, it is compiled. Wait, Mojo is compiled? I actually don't remember that part of it. Whether it was compiled or interpreted. Hold on, let me look into it again. Mojo programming language. Mojo is a new programming language designed to bridge the gap between Python's usability. I mean, I've looked into this before. Uh, that unifies high-level AI development with low-level systems programming. I would be interested in seeing. You know what? The fact that it's compiled might actually be why it's faster. Because is it possible that they're using something like LLVM, kind of like how Rust does? Is it possible they're using something like LLVM to compile a lot more optimized code? I guess we'll find out once. Wait, no, they might have mentioned it somewhere here, right? Um, just a second. Resources, models, recipe. Okay, you know what? I think there's a lot more available here now. There's a lot more available now than there was back when I had looked into it. Easy to read Pythonic code, bare metal performance, one language, any hardware. Um, Vendor lock-in is oh, they're giving reasons for, okay, all right. Developer experience ignored, memory bugs, and okay, they're giving all they're giving the reasons why they built Mojo. Yeah, it's like an LLVM. The guy who wrote it was involved with developing the LLVM and Swift. Interesting. Interesting. You know what? I'm glad that you brought up Mojo. I might actually look into it again. I'm also glad that you mentioned the compiled part because I was, for some reason, assuming that it's probably because they said it's similar to Python, Pythonic syntax. That's probably why I assumed it's interpreted and not compiled. Because when the language is compiled, then there's like it kind of changes things because there's a whole lot of optimization that can be done. The code that you're writing on a much higher level is probably going to be optimized to hell in a good way on a lower level, and that also kind of enables the whole cross-platform thing. It makes the cross-platform thing a little easier. Um, Check out mojolang.com. Oh yeah, there's no links allowed in the chat. But that's fine. I can look at Modular. I'm looking at modular.com because I think that's what I'd looked at earlier. What is Modulang a different? Hold on. Hold on. Modulang. Um, Mojo supports static typing, SIMD, and meta programming. The speed of Mojo is much faster. So and so, so and so. This is giving similar information to Mojo, isn't it? Modular made it, but the link is a better tutorial and okay, okay. You know what? I might check that out as well later on. Right now, hold on. Mojo, I'm looking at right now I'm looking at the um GitHub repo of Mojo. You mentioned that they're going to be making it open source soon. That's good news because that's good news because that would definitely make me a lot more interested in the language. And just in general, when the language itself is when the compiler and a lot of the tech surrounding it is open source, you have much more of the community being interested in it, being willing to develop for it, helping improve it, and stuff like that. It being closed source, it just I don't know. That was definitely one of the things that one of the things that kind of turned me off of the language. The other thing I think was the fact that at the time there wasn't Linux support, and you mentioned that now Linux is supported, which is a good thing. That means I can give it a try now. Also, I would be very much interested in seeing what the language is like now, especially knowing that it's a compiled language and you can get much more performance out of it. Who knows? Maybe um, I might be able to achieve what I'm trying to achieve with my Rust project. I might be able to achieve that with Mojo. Let me see what people are saying because there seems to be a Reddit thread saying asking this was 5 months ago. Someone asked, "Is Mojo language not general purpose?" Okay, the Mojo documentation and standard library repository got merged with the repo of some suite of AI tools called Max. The rest of the language is closed source. I suppose this language becoming a general purpose Python superset was a pipe dream. The company's vision seems laser focused solely on AI, with little interest in making it suitable for other tasks. Somebody replied, Mojo was never becoming a serious Python alternative in any real way as long as it's closed source. True. I guess this comes back to what I was talking about with like when when the community is involved in the project, you're able to get like a lot more out of it, and it seems then geared more towards the community. The development of it seems more geared towards the community, whereas if the thing ends up being closed source, then usually there's some kind of monetary motive involved behind that, and when something is being um, pushed by that motive, then I'm not sure the direction that it goes into is always going to be, you know, beneficial for the community. But I can wait and see. I can wait until the thing becomes completely open source. Actually, okay, let's look this up. Is Mojo programming language okay? The search says, is it free? Yes, the Mojo programming language is available for free the under the modular community license. This free version is intended. This free version. What do you mean this free version? So there's a paid version of the language? You can get started with the free modular community edition by downloading the SDK from the modular website. Welcome back. I was just reading up on so I googled is Mojo programming language free, and this is Google's own response, and then there's also a thing, but something caught my attention, which was It mentioned you can get started with the free Modular Community Edition by downloading the SDK from the Modular website. If they're explicitly mentioning free, what is what's what's paid? What exactly is paid here in terms of, well, I mean, if it's services that the website itself is offering or the platform itself is offering, that's a different thing, right? Cloud services and stuff. But like, are there any libraries or anything that are or anything about this language itself that would not be free? Because like cloud stuff being paid, that makes complete sense, right? If they themselves are paying for, you know, that cloud technology to run and maintain that cloud technology, then kind of silly to expect them to give it to you for free. But I'm talking about the language specifically. Do we have full access to this language? Also, is the language open source or not? Um, what is the status of the Mojo programming language? This was a year ago. Then Mojo slash modular, has anyone used it in a real project? A new simpler license for Max and Mojo. Mojo should be free. Okay, this is from the modular platform, from the modular website. As a programming language, it shouldn't be behind paywalls or hidden restrictions. Okay, let's open this up. And then somebody also asked the question back in 2023, which is making me wonder if I actually looked into this back in 2024, or because like by the time I had looked into it, it had already been out for a couple of months, maybe, I think. It's just that the time when I started seeing it blow up on, I think it was on X, because like I don't frequent that site very much these days, but like back then I was. Um, I think this was maybe a year and a half ago, because I mean we're already at the end of 2025. Okay, so this is off of the modular website. It says we are thrilled to announce a major simplification of our community license for Max and Mojo. What is Max? Let's look at that. Modular.com, Max, a high performance inference framework for AI. Max provides powerful libraries and tools to develop, optimize, and deploy AI on GPUs fast. Okay. Oh, is this kind of like Hugging Face's Accelerate framework? Though with Accelerate, it seems like it generates code for you. I'm wondering if this framework kind of provides its own runtime to run on run stuff on the GPU, or maybe it writes optimized code for you. Um, but yeah, okay. I don't think I need to look too deep into this because I might end up getting distracted. Serving inference framework and Mojo is a programming language. Let's continue reading this. Right. So we are thrilled to announce a major simplification in our community license for Max and Mojo, one that makes it easier than ever for everyone to dive in, experiment, and build great things. Over the past few months, we've been listening closely to the community in our forum, via our Discord, at meetups, and through countless chats and emails. The feedback was clear. Our license felt restrictive and confusing. Folks weren't sure which parts were free, which parts cost money, or how Max and Mojo fit together. Then Mojo should be free. As a programming language, it shouldn't be behind paywalls or restrictions. The barrier between Max and Mojo was blurred. People wanted a clean, easy to understand split. Right. Um, a new, simpler approach. How old is this blog post? This is from April this year. It's not that old. It's a couple months old. Okay, a new, simpler approach. we took this insight and just set out to simplify it. The result, a straightforward a straightforward tiered license that covers all the bases. Non-production commercial, everything is free. Use Max and Mojo on any device for any research, hobby, or learning project. TLDR, no device limits, no hidden clauses, just go build. They mention everything is free. Non-commercial, non-production commercial. Okay, then production commercial on CPUs and NVIDIA, also free. Run your live applications, internal tools, or paid services on x86 or ARM CPUs or NVIDIA GPU. TLDR, full access to both Max and Mojo at zero cost. Production commercial on other accelerators. Free up to 8 GPUs. Free up to 8 GPUs. Wait, that's crazy. Hold on. Did they say they're giving like free resources as well? Free cloud resources? No, I'm gonna have to look into this further later on. But yeah, I will check this out. I will check this out. Serve an open source LLVM in minutes. No, it says LLM. GPU required. We recommend using an NVIDIA so-and-so or AMD so-and-so. Okay. Max can... Oh, I think this has to do with Max. This has to do with Max. Okay, you know what? Thank you for letting me know uh, about the stuff that's changed with Mojo now. I might look into it again. In fact, hold on. Is Mojo open source? Mojo is partially open source. Its standard library is open under the Apache license, allowing contributions, but the core compiler remains closed source for now as it's still maturing. The developers, Modular, plan to open source the entire language by 2026, focusing on building the core first before opening it up to the broader community, opening it up for broader community-driven development. Okay. Okay. All right. Cool. Cool. Okay. Let's get back to this. Now, how do I make this image bigger? What if I clear this and then try... No, the scale is still small. I think I can change... I think I can control the size. Kitten, iCat, help. Okay, place, background, scale up. When used in combination with place, what does place do again? Choose where on the screen to display the image. The image will be scaled to fit into the specified rectangle. The syntax for specifying rectangles is this by this and that by that. All measurements are in cells, i.e. cursor positions, with the origin being at top left. You know what? Sorry for distracting. No, it's all good. It's all good. I usually end up distracting myself with like some other topic. So if you didn't do it, or someone else didn't do it, then I was going to end up doing it myself. It's all good. Thank you for the information, though. I'm going to test this out. It'll cause images that are smaller than the specified area to be scaled up to use as much of the specified area as possible. Right, so I'm gonna test this out right now. Place. Right, kitten, iCat, place. I don't know. Hold on. First, let's graph underscore output dot png. Okay. Here I don't know how it's gonna go to the top left exactly, if the top left already has like text in it, but let's see what it does. And let's give, I don't know, 100. The screen is much bigger than that. Let's give it 500. No such file in directory. Where exactly is are the options supposed to come at the beginning? Okay, options and then, oh, options and then this. So, right, let's do this. And then graph underscore output dot png. Invalid place specification. I probably need, oh, hold up. Wait. Yeah, that makes sense. Because it's supposed to be width by height at top. Okay, all right, okay. Width by height. So what I was trying to specify was here. So 500 by 500, and here we want to start there. It's still saying invalid specification. I think it's because I was using commas. It's supposed to be this. That's interesting. Hold on, clear this. It chopped the thing up. I wonder if that's happening because of rendering in Tmux. Let's try that again. Hold on. Clear. Actually, we can do clear here, and then we can display the thing. Okay, 500 by 500. Let's not start there. Let's start at, I don't know, let's say 50. Yeah, this is getting broken up. I'm not sure why that is exactly. And I wonder if I use the scale up option. Failed to transmit so-and-so image is too large to be displayed using Unicode placeholders. Maximum size is that. All right, let's turn it down to this. So now it's displaying in that corner. That's interesting. Um, yeah, you know what? I'll look into this. I'll look into this later. For now, let's continue with. Hold up. We need to go all the way back here and print. So this is our graph. I can open up this graph later on. I need to look into the size thing with these images because I don't remember. What is the size? What is the size of these? Does it mention the size in Yahtzee maybe? It's a 12 by 12 image. Well, the size is not mentioned here, but fortunately it's mentioned in the graph. I also didn't know that you could specify the attribute in that way. I wonder, hold on. Graph output. I just realized something. This is a PNG that we are looking at, yet what's been what's being read from this PNG is the the digraph. This is all dot code inside it. Let me. We should be able to open this image here. There's PNG and PNG.png. I don't know what each of these does. Okay, let's open this up. That's a digraph. Let's open this up. This is just garbage. So this is probably an actual image. What what have I been opening here? How is it that iCat is able to read? So then this is not back up, dude. Uh graph.render, graph output.png. So this is not required, right? So for the time being, let's, you know what, let's delete this and also delete this. And then here we'll open up Yahtzee and delete both of these and re-export this. Okay. Now, if I open up Yahtzee and look at this, okay, so now there's two images. One is this and one is this. So I'm guessing it's not opening that. It's writing. It's writing to that, but it's not opening that. It's opening this, which is crazy because yeah, how is this working? Okay, let's try .png.png. Okay, that does the same thing. I'm kind of confused here. However, if the if the file exists over here, maybe I could just change the size. Let's make it that and see. Let's remove all of these options. iCat. That's not bigger. I think that's bigger. Yeah, this one is smaller. And wait, can I just define graphs and pass them to iCat and then iCat can render out the entire graph? I didn't know that that's possible. Let me try something here. Let's create some graph o1 dot dot. Okay, here we'll do digraph some graph o1, and then we'll do node o1 connected to node o2, node o2 is connected to node 03 and also node 04. Okay, let's try to pass this in. That's crazy. I didn't know iCat can actually render these dot files for you. That's insane. Or it's possible that iCat is internally checking if dot is installed and then it's using dot to do the rendering. That's a possibility. You know what? That's a possibility. Yes, that is very much a possibility. So keeping this in mind, keeping this in mind, what was I supposed to? This is the small version, and this is the big version, which is interesting because, so if I make this 220 by 220, hold on, where's the cursor? Okay, it's not all that bigger. Okay, there's a bit more to explore here, but hold on for a second. I need to take a short break. I will BRB in a couple of minutes. I'm back. Sorry about that. Uh, break ran a little longer than I expected. Okay, so we are gonna get back to this. Holy shit, we were supposed to be. Um, I mean, we're technically still doing that. I just got kind of distracted with doing graph viz stuff and actually visualizing the computational graph. I'm still kind of puzzled by this behavior where there's so like okay, if you look at the code is here. Where did I put it? Just a second. Yeah. Um, wait, what was the thing for moving buffers? I think there was a thing for moving buffers, right? Would it be window, move window to so and so? Okay, let's try this. Yeah, that's nope, that's not. Yeah, no, that's window. That's not moving the buffer. There was a thing for moving the buffer itself. I can't remember exactly what it was. I'll look into it later. Anyways, so this is kind of interesting because we specify a name here, graph output. We specify the format, and then what the tool does is it creates the graph in this file, but then it creates the image in this file. Both of them are .png, by the way. Both of them are .png. It's just that one of them is this. One of them is the actual like uh, dot syntax, the dot code, and the other is the rendered version of that dot code. I don't have that open here. That is this. Because this is the rendered version, that's why it looks like garbage, because this is the actual image. This is the image. I believe over here, so it says PNG. There's probably a magic number at the beginning of this file to say that it's PNG. Um, but yeah, that's kind of interesting. I need to look into the working of this tool, how exactly this tool works and what exactly it does, or maybe I can just ask Gemini about it. Speaking of Gemini, there was this response from Gemini that I was reading. Oh shit! I accidentally hit a key. Okay, yeah. So here's the response that I was reading. Let me scroll here. Okay. So I said, okay, that's awesome. We'll look into that later. I was talking about TorchViz and GraphViz. Then I said, for now, would you mind explaining to me again, or perhaps even giving me a conceptual understanding of what's happening in backward, what concepts are being utilized, and maybe a bit of an idea of the math behind of the math being used. But don't go too deep into that because I don't know calculus. Okay. So this was basically me trying to get Gemini to explain uh, the calculus that's being used in order to first of all generate the gradients, but then also use those gradients to do backpropagation and actually no, the gradients are generated after the process of backpropagation. That's what's happening, right? That's why we do backpropagation, even in the network. So we can generate the gradients starting from the end of the network, which is like the output of the network, and then going like all the way backwards towards the front of the network, or towards the beginning of the network. Anyways, of course, this is the central mechanism of all modern deep learning frameworks, so reviewing it from a different angle is a fantastic idea. Let's break it down conceptually. Imagine your code not as a series of commands, but as a process of building something. The concept, a system of influence. Think of your entire set of operations as a system that produces a single final number, which is the total sum. We'll call this the output. Okay, we'll call this the output. The goal of backward is to figure out how much influence each initial input, which is tensor x and y, had on that final output. Back up, let's read that again. Um, think of your entire set of operations as a system that produces a single final number. That's called our output. And then the goal of backward is to figure out how much influence each initial input had on the final output. Okay, this influence is the gradient. It answers the question, if I slightly increase an input number, then by how much does the final output change? The process, chaining together local knowledge. The backward call triggers a clever two-part process that works in reverse. Sorry, zoned out. Okay. The backward call triggers a clever two-part process that works in reverse. Each operation knows its own local derivative. This is the key insight. PyTorch has a pre-programmed handbook for every mathematical operation. This handbook tells the operation a simple rule. If a gradient signal comes to you from the output side, here is how you should modify it and pass it back to your inputs. Let's look at two rules from this handbook. For a sum operation, the rule is simple. The influence of A on Z is 1. The influence of B on Z is 1. What? For a sum operation. Okay, so Z is our result and Z equals A plus B. The rule is simple. The influence of A on Z is 1 and the influence of B on Z is 1. So it just passes the incoming gradient. Just a second. Okay, so it just passes the incoming gradient signal backward, unmodified to all its inputs. It's a simple distributor. So then the gradient, if Z is, um, oh, so we are calculating the gradient not for the output, but for the input. So the influence is the gradient, I guess. I think. I'm not sure. For a multiplication operation, the rule is what we discovered in the challenge. The influence of A on Z is equal to the value of B. The influence of B on Z is equal to the value of A. So to pass the gradient signal back to A, it multiplies the signal by the value of 1. No, by the value of b. Okay. To pass the gradient signal back to a, it multiplies the signal by the value of b. I think I wanna test this. I want to test this theory out. Yeah, yeah. I wanna test this out because, like, okay, it multiplies the signal by the value of b. So to pass the gradient signal back to a, it multiplies the signal by the value of b. Okay, okay, hold on. Backward chains these rules together. The backward call is the master command that starts a chain reaction. It's like a domino effect in reverse. Start at the end. Just a second. Um, just a minute. Just a minute. Sorry, I'm just doing something. Sorry, just a second. Okay. Sorry, I was busy with something. Okay. So, um, right. Um, I'm just reopening my stream on my phone so I can have chat open. Okay. So, um, continuing this, I forgot where I was. I think backward chain these rules together. Okay. Backward chains these rules together. The dot backward call is the master command that starts a chain reaction. It's like a domino effect in reverse. Start at the end. We start at total sum. The gradient signal at this point is just 1. We are saying total sum has an influence of 1 on itself. Okay, total sum has an influence of 1 on itself. Step back to the sum. Total sum was created by product tensor.sum. It looks up the rule for sum in the handbook. The rule says to just pass the signal back as is. So it passes um, the signal 1 back to product tensor. Okay, in this case, the final gradient that was calculated for the very beginning, which was the input tensors. I'm wondering what that whole thing would look like if it were um, being done for a neural network, for a feed-forward neural network. Because there you have multiple layers of matrix multiplication operations plus addition. Like each node is doing, actually, well, no, each layer is being handled as a matrix, like the weights of each. Hold on, no, I don't remember. I don't want to say I don't want to say that because I'm trying to remember. The input is, let's say, 4, right? Then yeah, how how is the data flowing through exactly? Is it that each node has a weight matrix that can be multiplied by the input, or is it that the entire layer is consolidated into one matrix? I'm gonna have to look at the Once we get back into feed-forward neural networks, then I'm going to have to look into the matrix shape, the weight matrix shape. Sorry, give me a second. Let me drink some water and then I can continue reading. Okay, all right. Let's continue reading. Okay, so it passes the signal back as is. So it passes the gradient signal 1 back to product tensor. Okay. Step back to the multiplication. Um, where, yeah, step back to the multiplication. Now the signal is at product tensor. It was created by tensor x multiplied by tensor y. It looks up the rule for multiplication. To calculate the gradient to pass back to tensor x, it takes the incoming signal 1 and multiplies it by the value. Oh, I was wondering why the numbers looked interchanged, like why it just looked like the numbers had been swapped. Like where was 1 coming from in that calculation? Because earlier over here somewhere it was mentioned that for multiplication, where where was it? It was mentioned somewhere here. Oh, I think it was here. For every operation, it's so and so. Yeah, the rule the rule is what we discovered in the challenge. The influence of A on Z is equal to the value of B. The influence of A on Z is equal to the value of B, and the influence of B on Z is equal to the value of A. It multiplies the signal by the value of B. So to pass the gradient signal back to A, it it multiplies the signal by the value of B. So the signal in this case is 1, and then that gets multiplied and passed back. I am interested in seeing how this is getting applied to the matrix, because like if it's being applied to one item, like then I can imagine that, but like how it's being applied to the entire matrix, I would like to see that calculation. Okay, where was I? To calculate the gradient to pass back to tensor y, it takes the incoming signal 1 and multiplies it by the value of the other input, tensor x. The result is tensor x. Arrive at the leaves. These calculated gradients, tensor y and tensor x, are passed back to tensor x and y, respectively. Since these are the original inputs, the leaf tensors, this is the end of the line. The journey is over. The final calculated gradients are saved in their .grad attributes. This actually really helps me understand this. Dude, this conceptual understanding has helped me understand this a lot more, especially because I never got a chance to learn calculus, and so this thing, the chain rule and all of that. I'm assuming chain rule is also a part of calculus. I can't say for sure, but like, yeah, this helped me understand it. Uh, rate of change. Rate of change was a thing as well, wasn't it? I believe, yeah, rate of change was a thing. Okay, the math concept in a nutshell, the mathematical principle being used here is called the chain rule. You don't need to know the formula, just the concept. The total influence of a start to finish chain of events is the product of the influence of each individual link in the chain. The total influence of a start to finish chain of events is the product of the influence of each individual link in the chain. Okay, all right. Backward is just a system for automatically applying this chain rule, moving from the final output back to the inputs using the simple local derivative rules that each operation knows. It's a chain of simple calculations that results in a powerful, complex calculation. That is very interesting. Um, could you also explain? Hold on. There was a thing that we had learned about deltas, or yeah, this. Okay. Oh, what did I just do? Oh, yeah, right. Um, okay. Could you also explain the df by dx and df by dy thing in a similar way? Okay, also, so I know we didn't get a chance, we didn't like dive too deep into this, like um as much as progress we might have made like when we first started this. We haven't made too much progress with this today, and that's because um I kind of got distracted with trying to visualize the computational graph using TorchWiz and well GraphWiz as well. And now we are reading this. So I mean, to a certain extent, we did still do research on this, which is great. We're gonna move on from this eventually. I'm just gonna read this um, response, and later on, I guess I'll continue with the lesson. I might actually continue with the lesson off stream, or I might do some of the other stuff off stream just so I can continue this on stream tomorrow, hopefully. Maybe, I'm not sure. Let's see. Okay, so that being said, let's look for someone to raid. There are a couple of people here. Okay, someone is doing a study session. Um, we get work done today. Okay, this is a VTuber. This is a VTuber. Okay, then there's somebody doing cozy productivity. PhD dissertation defense. I don't think I'm able to raid this person. Yeah, I think we were going to yesterday, but then there was something preventing me from being able to raid them, which is why we didn't raid them. Just a second. Okay, okay. Digital library and TBR setup. What is this person doing? Okay, so I'm not sure what this person is doing. What about the other person that I found? Just a second. Okay, let's go to this person's stream. Their name is Marmalade Little. Marmalade underscore little. Um, and they started their stream like 5 minutes ago, which is great. So we're gonna go check out this person. Hopefully they don't have any settings that prevent small raids. Uh, yeah, okay, we are good to go. Okay, so that's gonna be it for today's stream. Scott LB, did I read that right? I think so. No, Scott B. Scott B. Scott B. And um, I'm Gajid. Thank you for hanging out and chatting. Scott, thanks for the follow as well. Anyone who might have been lurking in the chat, thanks for hanging out. Once again, I'm super happy about this streak that we've got going. I've been streaming every day for a good like 2 weeks plus now, and I'm hoping the streak continues. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.